Okay, so here's a brief lesson on how to take volume and mass data and use it to create a graph that might tell us a little bit about the nature of that substance. So what we did in class was we found a lot of different pieces of modeling clay, and the class measured the mass of each piece first using an electronic balance and uh, accurate to the nearest 2 decimal points in some cases. And then we used OverflowCAN to figure out the volume using graduate cylinders. So what we've got here with Excel, our mass is going to be on the y-axis and our volume is going to be on the x. And so with Excel, we flip it around and put the x axis first, whereas sometimes you might see when you're graphing in science class that the y column goes first. So anyways, here's all the data that we collected, and we'll take a look, and we'll notice that there may be some outliers, some things that don't quite fit the pattern, but we'll take a look and see. So we've highlighted our data, and we click on Insert, and remember in science when we've got two sets of qualitative data that we want to compare, we're going to use a scatter plot. And we choose to use the scatter plot that where we don't join the lines up. And so we get our graph, and we can see here that there's definitely a trend in the line. We can see a couple outliers. There's one right there that looks like an outlier right there. But if we take a look at all the data, it seems that we've got a nice pattern developing. So of course we would, if we're going to ever make a graph, we're going to put in our titles here. So this is volume, and that's cubic centimeters. And then we have our mass. And this is in grams. And we're going to rename our title at the top. All right, mass versus volume of pieces of clay. Real simple. So now we want to add a trend line. And so this is important. So we've created a trend line right here. And in creating this trend line, we can get a lot more information from this. Remember, the reason why we did this is so that we can predict what if my clay was a little bit larger, what if it was a little bit smaller. If I knew the volume, could I predict the mass? Is there a fundamental property at play here? Can I use this information to determine maybe what's in the clay or what type of clay it is? So with my trend line, I'm going to right click on the line and I'm going to format the trend line. And I'll just pull me out of the way here so you can see what's going on. And so here we've got this. We're going to just scroll down a little bit, and we're going to set the y-intercept at 0. And that's just going to tweak the line slightly, because if we had 0 mass, of course we would have 0 volume. And the big thing here is we're going to display the equation on the graph. And we can get rid of this. Pull me back. Well, we'll just leave me right there, I guess. And so now we've got the equation of the line. Now, why is this important? How is the equation of the line useful for what we're doing? Well, I'm just going to write out the equation. The equation of the line is usually y equals mx plus b. Now, in our case here, the b is the y-intercept. In this case, it's 0, which is why you don't see anything here other than the y equals 1.6808x. So if I switch and I put in mass for y, mass equals 1.6808, and I put in volume for x because that's what it represents, I now have a relationship. If I want to find my mass, I multiply my volume by 1.6808, and that gets me my mass. If I want to find my volume, I would do the opposite. I would divide the mass by 1.6808, and that would give me my volume. And it turns out that this number right here, which would be m in the line and the equation of the line, which we would call our slope, also represents a fundamental property of all matter, and that is, in this case, our slope is equal to density. So the density of this clay is equal to 1.68, and we'll just leave it at that, 1.68 grams per cubic centimeter, or grams per milliliter, because cubic centimeters and milliliters are interchangeable. And there you go. So plotting the mass over the volume of a pure substance and getting multiple samples to test. And in some cases you'll have some weird outliers, but if you get enough samples, you get a nice line of best fit, and from that you can use some math tools to find the equation of the line. And if you know what that equation of the line represents, you can determine the slope of that line, and that slope is equal to the density. From there, you can go and make a whole bunch of predictions. What if your volume was 60 cubic centimeters? What would the mass be? What if your mass was 150 grams? What would the volume be? Now all you have to do is plug it into this awesome formula, and you can solve.